Look around you. What do you see? Perhaps a book, a tree, or another person? Everything you've ever touched, smelled, or seen is made of atoms. These tiny particles are the fundamental building blocks of matter, the very essence of existence. Just like the vast universe, atoms have their own internal structure, a microscopic world governed by the laws of physics. At the heart of every atom lies a nucleus, a tiny point 100,000 times smaller than the atom itself. Yet, this infinitesimal speck houses almost all of the atom's mass. The nucleus is a bustling hub of activity, home to protons and neutrons, particles bound together by the strongest force in the universe. Orbiting this nucleus is a cloud of electrons, flitting about in a constant dance, their energy levels determining the atom's interactions with the world. Imagine a bustling city. The nucleus is like the city center, a dense core holding most of the city's population, the protons and neutrons. The electrons are like the city's inhabitants, constantly moving, their energy levels determining their roles and interactions. This intricate dance of particles, this carefully orchestrated symphony of energy and forces, gives rise to the incredible diversity of our universe. Let's journey into the heart of the atom, into the bustling nucleus. Here we find the protons, particles that carry a positive electrical charge. The number of protons, known as the atomic number, defines an element's identity. Hydrogen, the simplest element, has just one proton. Carbon, the backbone of life, has 6. Alongside protons reside neutrons, particles with no charge but with a mass almost identical to protons. Together, protons and neutrons determine the atom's mass. The balance between these particles dictates the stability of the nucleus. Too many neutrons and the atom can become radioactive, shedding excess energy in a bid for stability. Think of protons and neutrons as the bricks and mortar of the universe. Their numbers and arrangements determine the variety of elements, from the lightest, hydrogen, to the heaviest, like uranium. These elements in turn form everything we know: the air we breathe, the water we drink, the ground we walk on. While protons and neutrons reside in the nucleus, electrons exist in a cloud surrounding it. Unlike planets orbiting a star, electrons don't follow precise paths. Instead, they exist in a haze of probability, their locations described by mathematical equations. These equations tell us the likelihood of finding an electron in a specific region at a given time. Electrons determine how atoms interact with each other. They can be shared between atoms, forming strong bonds that hold molecules together. The way electrons are arranged in an atom's outermost shell dictates its chemical properties, its tendency to bond with other atoms, and the types of bonds it forms. Imagine a beehive buzzing with activity. The bees, like electrons, are constantly moving, their exact positions uncertain but their overall distribution creating a pattern. Electrons, in their constant motion, determine the reactivity of an atom, its ability to form bonds, and ultimately, its role in the grand tapestry of the universe. Section 4. The Atomic Symphony: How Elements Find Their Place. Each element's unique properties arise from the interplay of its protons, neutrons, and electrons. The number of protons defines the element, while the balance of protons and neutrons governs its stability. The arrangement of electrons dictates its reactivity and how it bonds with other atoms. This delicate balance of forces plays out on a grand scale, shaping the universe as we know it. Stars, fueled by nuclear fusion, forge heavier elements from lighter ones, releasing tremendous energy in the process. These elements, scattered across the cosmos by supernova explosions, become the building blocks for new stars, planets, and even life. Think of the periodic table as an orchestra, each element a unique instrument. The protons, neutrons, and electrons are the musicians, their interactions creating a symphony of elements, each with its own distinct voice, contributing to the grand cosmic composition. Section 5. From Stars to Smartphones: The Impact of Atomic Understanding. Understanding atomic structure has revolutionized science and technology. It forms the bedrock of modern chemistry, allowing us to understand chemical reactions, synthesize new materials, and develop life-saving drugs. Our knowledge of atomic structure underpins nuclear power, providing a source of energy that, while controversial, has the potential to meet our growing energy needs. From medical imaging to telecommunications, from agriculture to manufacturing, atomic theory touches almost every aspect of our lives. The smartphones we use, the computers we rely on, even the food we eat, all are products of our understanding of the atom. As we delve deeper into the quantum world, the realm of the very small, we continue to unlock new secrets of the atom. These discoveries promise to further revolutionize our world, leading to new technologies and a deeper understanding of the universe and our place within it.